Okay, so this is 11.7 continued. So in the spherical coordinate system, a point P is represented by rho. So it looks like a P, but it's called rho, a Greek letter rho, theta, and this is called phi, this angle, where rho is the distance between P and the origin. We'll look at the picture in a second. Theta is the same as the angle in cylindrical, and phi is the angle between the positive z-axis and the point P viewed as a vector. Also, the phi angle goes between 0 and pi. So I've drawn a picture here off the side over here. So here's my point up here, P, and here's my rho vector. And the phi is the angle between the positive z-axis and the rho vector. And you can project it down into the xy plane. You'd have an r over here. This would be z here. Then you have your x and y. So let me show you with a piece of paper and some pens. So a better way of looking at this. Okay, so here's the xy plane, say. So say the z then is up that way. Then I put my point on this say the point is the tip of this blue pen here. So it would be like that. The phi angle would be here. So the angle between the positive z-axis and the point. So it'd be here. The z value would be this yellow one here, down. And the r would be from here to here. Let me draw that in. So the phi would be the angle in the from the x-axis up to the. So pretty much, if you project this blue vector down onto the xy plane, it would create the r guy down here. It's like the shadow, and then you have a theta is the angle between the x-axis and the r up here. Okay, so let me talk about now why the phi angle. So again, the phi angle, say this is the z-axis. The phi angle is here. So why that has to be between 0 and pi. So if you go from 0, that'll be 0 right there. That'll be pi over 2 there. So if you go from 0 to pi over 2 and then let the theta angle vary, it will sweep out circles here. So if I say fix an angle there and let the theta vary, it would sweep out a circle all the way around. So if I let it go between 0 and pi over 2, it would sweep out the top half of the sphere. So if I let it go between pi over 2 and pi, it would sweep out the bottom half of the sphere. Therefore, the phi angle just needs to go between 0 and pi. If you let it go between 0 and 2 pi, it would go around the sphere twice. Okay, so don't worry about that too much right now. Okay, so let's go back. Okay, so we're back up here again. So hopefully this makes more sense now, this drawing I've made. Okay, so let's make some observations. Let's look at how we find, well, actually, let's make, first observation is the z-axis over here and this dotted line here are parallel. So if they're parallel, it means that that's phi, that would have to be phi also. So that's the first observation. That angle has to be phi. Okay, so this guy's phi. Now I'm going to be looking at the this right triangle has rho as the hypotenuse and phi here, and this right angle down here to this guy here. Looking at that one, let's look at, say, the cosine of phi. So the cosine would be the adjacent, which would be z, and divided by hypotenuse. Hypotenuse would be rho. So let me write here. So we have cosine phi is adjacent over hypotenuse. The adjacent side is z. Hypotenuse is rho. So then multiplying both sides by rho, you have z equals rho cosine phi. Okay, let's now do the same thing with sine phi. So let me write that. So I'll have sine phi is opposite over hypotenuse, but the opposite side would be r over rho hypotenuse. So solving for r, then r equals rho sine phi. And then we'll have our x and y the same as they were in cylindrical. Let me write it here. So we'll have our x equals r cosine theta, y equals r sine theta. You can replace r with rho sine phi, but I'm not going to do it here. I'm just going to leave it like that for now. And then let's make another observation. The first one is that r squared equals x squared plus y squared. That's from the right triangle down here. Because you have x and y as two legs, r is hypotenuse, so r squared equals x squared plus y squared. And then in this other right triangle up here, you'll have r as a leg, z as a leg, and rho as a hypotenuse. So you'd have then rho squared equals r squared plus z squared. So in place of r squared here, then you can replace it with x squared plus y squared. So let's do that. So making that substitution, then you'll have then x squared plus y squared plus z squared equals rho squared. Okay, so now let's take a look at an example. Okay, so I'm going to erase this now. All right. Okay, so an example, convert point from spherical coordinates to rectangular coordinates. So our point here is 2, 7 pi over 6, 3 pi over 4. So the 2 is our rho, the 7 pi over 6 is our theta, and the 3 pi over 4 is our phi. So let's start converting to rectangular. So first we'll use our z equals rho cosine phi. Let me write that here. So we'll have z equals rho cosine phi. The rho is 2, the phi is 3 pi over 4. So in the second quadrant, so it's going to be negative square root of 2 over 2. So it'll be then 2 times negative square root of 2 over 2. So it'll be just negative square root of 2. Let's find the r next. So our r is equal to rho sine phi. Okay, so we have r equals rho sine phi. Rho again is 2, phi is 3 pi over 4. So sine of 3 pi over 4 is square root of 2 over 2. 2's cancel, we get square root of 2. Let's next use our x equals r cosine theta formula. So we'll get then r equals cosine theta. Our r is square root of 2, so it'll be square root of 2. Our theta is 7 pi over 6. So it'll be cosine of 7 pi over 6. So reference angle will be pi over 6, and the cosine of pi over 6 is square root of 3 over 2. This in the second quadrant, so it'll be negative. So let's be then right here. So it'll be negative square root of 3 over 2 for that, and then multiply by square root of 2, so it'll be negative square root of 6 over 2. Let's find y next. So that y equals r sine theta. R again is square root of 2. Theta is 7 pi over 6. Okay, sine of 7 pi over 6 would be 1/2. So it's going to be then, let me write out here. Sorry, I'm incorrect. This is in third quadrant, the sine would be negative 1/2 here. So it'll be square root of 2 times negative 1/2. So it'll be negative square root of 2 over 2. So you have this. Now ready to write our point in rectangular form, so let's do that. So in rectangular coordinates, then our point, so that would be in the form x, y, z. So our x was negative square root of 6 over 2, our y was negative square root of 2 over 2, and our z was negative square root of 2. Okay, so we're done with this example. Let's look at another example. So let me erase this. Okay, so next example, this is actually from practice quiz 1, number 5. It says convert the point from rectangular coordinates to cylindrical and then to spherical coordinates. So our point here is x, y, z equal to 2, 1, minus 2. Okay, let's first find the row vector. Okay, so let's make an observation. So using what we derived, we had rho squared equals x squared plus y squared plus z squared. So rho then would be the square root of x squared plus y squared plus z squared. So my x is 2, y is 1, z is minus 2. So we 2 squared, 1 squared, minus 2 squared, which you can check as square root of 9, which is 3. So that's our rho. Okay, so now let's find the phi angle. So let's first find the cosine of phi. So the cosine of phi would be z over rho. We derived that in last when we derived the spherical coordinates. So our z is -2 and our rho we just found is 3, so let's write that here. So again, the z was -2 and the rho we just found was 3. Now recall the phi angle is between 0 and pi, or 0 and 180. And the inverse cosine gives an answer in that region, so we can just take inverse cosine on both sides here. So let's do that. Okay, so we'll have then our phi angle is inverse cosine of -2/3, and I'll let you check if you plug this in your calculator, go inverse cosine of -2/3, it's roughly equal to 131.81 degrees. Okay, so we found our phi. Let's next find our r. Okay, so we write some stuff up here. So r is equal to rho sine phi. We know rho, it's 3. We know phi now, it's 131.81. So let's plug into that. So plugging in, then we have 3 sine 131.81. Make sure you're in degrees here when you do this. So it should end up being 2.24 roughly. Okay, let's keep going. I'm going to use cosine theta equals x over r. So our x is 2, or r we just found is 2.24. And notice that the x and y are both positive up here. That implies your theta angle will be in the first quadrant. So we can just take inverse cosine on both sides and it will give us the correct answer. So let's do inverse cosine on both sides. So taking inverse cosine on both sides, we'll have inverse cosine of 2 over 2.24. What you can check is roughly 26.8 degrees. So now I think we got everything to write it in spherical and cylindrical. So let's do that now. So hence then our spherical coordinates will be rho, theta, phi. So rho we found was 3 here. Our theta we found was 26.8 and our phi was 131.81. We can also write our cylindrical. Let me do it here. So our cylindrical coordinates then will be r theta z. So r was 2.24 here. Our theta is 26.8 and our z was up here -2. Okay, so we're done with this example. So let's look at another example. So I'm going to erase this now. Okay, so next example, it says find the equation in spherical coordinates for the surface represented by the rectangular equation x minus 1 squared plus y squared plus z squared equals 16. This would be the equation of a sphere where the center would be 1, 0, 0, and the radius of the sphere would be 4. Okay, so we need to convert this to spherical coordinates. Okay, so let's first expand this guy. So it'll be x squared minus 2x plus 1. Let me write that here. So we get this then. Now I want to isolate the x squared plus y squared plus z squared because I know x squared plus y squared plus z squared is rho. So let me add 2x to both sides and subtract 1. So take these. So we're going to add 2x here and subtract 1. Let's do that. So doing that, so adding 2x, subtracting 1, we'll end up with x squared plus y squared plus z squared equals 15 plus 2x. Now this part here is equal to rho squared. I can replace that. Let's do it. So the x squared plus y squared plus z squared is rho squared. And recall that x is equal to r cosine theta and r is equal to rho sine theta. So let's replace this x now. Okay, so over here, then x will be rho sine phi cosine theta. So you can replace the x here now with this guy. That's what I did here. So I replaced the x with this whole thing here. And therefore we're done because we've written it now So pretty much it was written in terms of x, y, and z initially, and our objective was to write it in terms of rho, theta, and phi, which we have done here. So this will be our answer right here. So we're done with the question. All right, so let's do one more example. Okay, so next example, this is from practice quiz 1, number 6. It says find an equation in rectangular coordinates for the surface represented by the spherical equation, then sketch graph. So here's our equation, phi equals 3 pi over 4. Okay, so let's try and visualize what this would look like in spherical coordinates. Okay, so say here, this is my z-axis here. So the phi angle is 3 pi over 4. So that'd be down here, this angle here. So imagine that angle's fixed now, and this, I can rotate this around, but the angle has to be fixed here. If I rotate around, it would create a cone down here. We rotate this guy around, with the angle 3 pi over 4 fixed. So let me draw that here. So it looks something like this, so like an upside down cone. So again, the angle from the z-axis to here would be 3 pi over 4 all the way around here. Okay, now let's change it to rectangular coordinates, so let's make some observations. First observation is z equals rho cosine phi, but phi here is 3 pi over 4, so z would be rho cosine 3 pi over 4. Cosine 3 pi over 4 would be negative square root of 2 over 2, so it would be negative square root of 2 rho over 2. That's my z. Let's find my r next. So my r is rho sine phi. Again, phi is 3 pi over 4, so it'll be rho sine 3 pi over 4. Sine of 3 pi over 4 is square root of 2 over 2, so it's going to be square root of 2 rho over 2. And then note here, these are both the same, except they differ by a minus sign. So in particular, r squared will equal z squared, so let's note that here. So r squared equals z squared. Again, because they both are the same except they differ by a minus sign. And also note that z is negative from up here, because we have a negative here. Okay, so we have z is negative. So we also know that r squared is equal to x squared plus y squared. So let's note that. Okay, so we have x squared plus y squared equals r squared, but we've just shown that r squared equals z squared, therefore x squared plus y squared equals z squared, and also z is less than 0. So this would be our equation in rectangular coordinates right here. So there's our answer here. Okay, so we have our graph and we have our equation in rectangular coordinates. So we're done. Okay, I'm going to leave the video here. So let's leave it here for now. So we're done with 11.7.